Good evening, everyone. So, welcome to my YouTube channel, Rank-nullity. So, today we are going to see seventh lecture on linear transformation. Today we will see some exercises on rank-nullity theorem. Okay, we have studied rank-nullity theorem in last lecture. So, let's start today's lesson. So, question number one. Question number one. Let T R square to R cube be a linear transformation defined by Txy is equal to x plus y, x minus y, y. What are find find nullity and rank find nullity and rank of T. Solution. Dimension of R square, because here R square and R cube are vector spaces over R. So its dimension over R is actually 2. That is finite. Okay. So what is null space of T? Null space of T, xy belongs to R square such that Txy is equal to 0, 0. Okay. So let xy belongs to null T. So this implies Txy is equal to 0, 0, 0. This implies x plus y, x minus y, and y is equal to 0, 0, 0. Okay. So comparing both the sides, we get x plus y is equal to 0, x minus y is equal to 0, and y is equal to 0. By using any of these, either this and this, we have x is equal to 0. So this implies xy is equal to 0. So this implies what is the null space of T? So null of T is actually contains 0, 0 element. So this implies nullity of T is equal to dimension of null T, that is going to be 0. By rank nullity theorem, we have nullity of T plus rank of T is equal to dimension of R square. Nullity is 0, rank is dimension of R square is 2. So this implies rank of T is equal to 2. Okay. Question number 2. Let T R cubed to R square be a linear transformation defined by T x y z is equal to x minus y, y minus z. Find nullity and rank of T. Solution. So let x, y belongs to null of T. Then this implies T x, y, z is equal to 0, 0. So this implies x minus y, y minus z is equal to 0, 0. So this implies x minus y is equal to 0. So this implies x is equal to y and y is equal to z. So this implies x, y, z is equal to x, x, x. So this implies null of T is x subject 1, 1, 1. X belongs to R. It means span of so this implies is a basis for null T. So this implies dimension of null T is equal to 1. So this implies nullity of T is equal to dimension of null T is equal to 1. This implies nullity of T is equal to 1 by rank nullity by rank nullity theorem. We have nullity of T plus rank of T is equal to dimension of R cube. That is one rank of T we need to find, and that is 3. This implies rank of T is actually 2. Question 3. Let T R squared be a linear transformation. Defined by Pxy is equal to x0. Find nullity and rank of T. Solution. Let xy belongs to null T. This implies Pxy is equal to 0, 0. It means xy is equal to 0, 0. It means x0 is equal to 0. So this implies x is equal to 0. This implies xy is equal to 0, 1. So null T that is equal to that is equal to five y 0 1. So null t is equal to 0 y belongs to R, that is equal to y 0 1. Y belongs to R. So this implies span 0 1. So this implies B is equal to 0 1 is a basis for null T. So this implies nullity of T to dimension of null T, that is equal to 1. So this implies null T is equal to 1. By rank nullity theorem, we have rank nullity theorem, we have nullity of T plus rank of T is equal to dimension of R square. Nullity is 1, rank is, we need to calculate, this is 2. So rank of T is equal to 1. So today's lecture of this, if you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next time.